Good morning, Trig. This is another lesson that's going to take us some time. So, 57, lesson 57. The first part covers phase shifts and sinusoids. So we've gone over the center line, which is your vertical shift, and we've gone over the amplitude and a reflection. And so now we're moving on to whether our sinusoid has been shifted horizontally to the left or to the right. And so this is all about being able to determine where the phase shift occurs. And I've written that here. So for a sine, we can determine the phase shift by the point on the center line nearest the origin on the way up. So I will go over that as we look at graphs. Cosine, however, is really simple. Cosine is just the peak nearest the origin. So just to review, remember sine, our graph of sine should start at 0, 0, and then head to the right. Cosine, however, starts on the y-axis at 0, 1. So just a little review of how we determine those. So I want to go over the equation and what we know so far and what we're adding to it. So here's how we'll write. And this is how I go over it in later sections. So the book might use different letters. Here are what the letters we're going to use. This is in general form. And this is all the pieces. So we have covered that this should be our center line. It's also our vertical shift. The graph has been shifted from the x-axis either up or down. Now this negative here would be the reflection. We've covered that. B is our amplitude. We've covered that. So today there are two new pieces. We're going to go over this, which is our phase shift. Now remember, it should be opposite. So theta minus 30 degrees is really positive 30 degrees to the right. And if it said theta plus 30 degrees, that's really a negative 30 degrees to the left. So remember, it is opposite. The second piece we're going to go over, and that's in 57.b, is period, but we're going to leave that for now. But this does represent our period coefficient. So it's 3c is 360 divided by this should be 360 divided by, this is the complete cycle, equals c, or it would be in radians, which would be 2 pi. Now, really quick, remember it's theta if our graph is in degrees, and we use x if our graph is in radians. Okay, so I'm going to do some examples with you so this doesn't look like a bunch of gibberish. Okay, so here is the first one. All right, so write an equation of the sinusoid as sine and cosine. They want us to do both with a phase angle. So they are telling us that this graph has been shifted, and that's really, really important to know. That helps us determine whether it's been reflected and all that stuff. So they want us to write both. So let's start with, we'll do sine in yellow, and I'll do cosine in orange, and a lot of these pieces are going to be the same. So let's first, I'm going to write the general form up here, y equals a plus or minus b cosine c of theta minus d. Now, we're not dealing with periods so far, we're just dealing with phase shift, and this can be cosine or sine. So let's start with our center line. Now, they're not going to mark it anymore. Usually, you're going to have to figure out what it is. So this goes from 6 to 2, and I'm looking for a number in the middle. So 6 minus 2 means these have a distance of 4, but this has to be halfway, so I'm cutting it up. So 2 units. So if I went 2 units to the left of 6 or to the right of 2, this should be at 4. right? 4 would be halfway between positive 6 and positive 2. So I know that my center line, or A, is at 2. And I also know that because it's halfway, that my amplitude is 2. Okay, so this is my center line, right? This is my amplitude. So far I have y equals my center line. This has not been reflected, so plus my amplitude. Oh, I'm sorry. My center line is at 4. And sorry. A is our center line. So my center line is at 4. That's always what we write first, is our center line, where this dashed line is, or where the center of our graph is. Then our amplitude, so the distance between the center line to the peak or the center line to the valley. Now I'm going to write the sine, and because it's in degrees, I'm going to use theta. Now I need to determine where this graph has been shifted. So when it comes to sine, we're looking at the point on the center line closest to the origin. So I have 2 spots that are close to the origin on the center line, but you're looking for the one in which you're reading this graph, it's on its way up. So at 60 degrees, we read our graph moving to the right. This is on its way up, versus this point is on its way down. So you're going to use this point here. Now that says negative 60, so in here it should be positive 60 degrees because it's negative. So I'm using this one because it's technically closest to the origin and on its way up. So that is my sine equation. Now let's move on to cosine. So cosine, very similar. Your center line is still at 4. My amplitude is at 2. Cosine. The difference is the shift. So for cosine, I should be looking at the peak nearest the origin. There's this peak and this peak, but this one is closest to the origin, and if I look down below, it's at positive 30. And here it should be opposite, so negative 30 degrees. And so there is cosine. So notice the center line and amplitude should be the same. The difference is their phase shift, because sine is on the center line and cosine is a peak. So let's try another one. Write an equation of this function as the sine curve, so they only want sine curve, with a phase shift, and that's misspelled. There's no S in front of phase. I will fix that on my master copy. So let's identify our pieces. My center line should be in between -5 and -7. Those are only 2 units apart, so I know my center line is at -6. Okay, so that is my center line. My amplitude is 1, so B equals 1. So far I have y equals my center line plus 1 sine. I don't need that 1 there, so you can erase it, but you also could leave it there. And I'm going to make it look like a 1 and not an L. Okay, now it's in degrees, so I know I'm going to use theta. So let's look for our phase shift. So I'm looking for a point on the center line. I have -90 and +90. But we're looking for the one on its way up, which would be the -90, right? This one, if I'm reading this graph, is on its way up. So if this is -90, if it was shifted to the left 90, I'm going to write +90 degrees. Now, know that there is more than one right answer, okay? I know you could write that this was reflected, but then that changes where the shift is. So this hasn't been reflected because my graph is moving up. Now, if you said this graph had been reflected, then I would probably use +90 because this point should be up here. But anyways, there is more than one right answer, okay? Number 3 says write this equation in terms of cosine with a phase shift, and then write in terms of sine. So cosine, right, would be the peak nearest the origin. This is at 225, this is 135. So I'm going to use that peak there, which is at 135. Okay, let's identify everything else they're telling me this is a -6 is at 4. So I'm finding the distance between them. That's why I'm subtracting. They have a distance of 10 units. To find the halfway mark, I would divide this by 2. That gives me 5 units. So 5 units to the left, the center line is at -1. Hope you can see that. And this would be my amplitude. So B is 5. A is -1. So y equals -1 plus 5 cosine. Now I already determined that the peak nearest the origin, this is 135 degrees versus this one is 225. Because it's positive, this would be theta minus 135 degrees. Should be opposite, okay? Now I'm going to work on sine. I know that my center line and my amplitude are going to be the same. The difference is the phase shift, because for sine, we care about where it crosses the center line. So I have this point at 135, but it's headed down. This point, 45, closest to the origin and on its way up. So 45 degrees was going to go in here. Sorry, this one I did in orange. So positive 45 would be minus 45 degrees. So those are the equations for this graph. Next one. And I particularly did this in radians so you could see the difference. They have asked us to use cosine. So cosine is the peak nearest the origin. I have 2 peaks, both are pi units away, so you could pick which one because they are both the same distance. Okay, so you could use the positive radian or negative radian, and the reason there's 2, they're both equal distance. Okay, so let's talk about my center line. It goes from 5 minus a -9. They are 14 units away. So in the middle would be 7 units. So this would be at -2. So y equals -2 because that is my center line. And that always goes first. This is my amplitude, because the center line is 7 units from 5 and 7 units from -9. My phase shift, I'm using x because it's in my graph is in radians. And I can either use the positive pi, which would mean minus pi. So this is one option. Or you could say y equals -2 plus 7 cosine x plus. You could use the negative one. Now the reason there's 2 here is because those are the same distance from the center. All right, so the period of the sinusoid has to do with a complete cycle. So period is the period is how many full cycles, I should put how many. The period coefficient in your equation, so which is the coefficient of c in general form, should represent how many full cycles occur in 360 degrees, or if it was in radians, that would be 2 pi. Now, a full cycle is the following. So in a sine function, and I should do sine and cosine, and I know that's not perfect, this is a full cycle, should include 1 peak and 1 valley. Now this should be 180, this should be 360. That is one full cycle. Now for cosine, you can measure you can go from center line to center line or peak to peak. But either way, a full cycle should be either 2 pi or 360 degrees. this coefficient will be how many cycles occurred in 360 or in 2 pi radians. So I'm going to do these with you. And I'm going to write this general form. So y equals our center line plus or minus our amplitude, our period, and then our phase shift. Now, in most cases, well, for now, they will not give you both. They will either give you a phase shift or a period change. They won't give you both for now. It's several sections later where they include both. Okay, so let's start with number 1. It says write the equation of the following, assuming there's no phase shift. So they're telling us this hasn't been shifted. Just focus on your period, amplitude, and center line. So there's no D, and they'll tell you that in the homework whether it is or whether it's not. Also, if there's no phase shift, it should be really obvious whether it's sine or cosine. So because this has started at my origin, I know that this is sine. This is in degrees, so I'll use theta. If this is 12 and this is 8, then my center line is at 10, which means my amplitude is 2. So let's start there. I know my center line is at 2. I have an amplitude, my center line is at 10. I have an amplitude of 2. I know this is sine. It hasn't been reflected because my peak is up here and not here. Now there is no phase shift, and I do have theta. My period is going to go right here. So let's look at a full cycle. From center line, I need to include one peak and one valley. So notice I have a full cycle, in 90 degrees. So from here to here, 90 degrees. So I would take 360 degrees and divide it by 90, and that gives me 4. That means there are 4 full cycles in 360 degrees. And notice that's true here. 1, 2, 3, 4. 4 full cycles. So because a full cycle occurred in 90 degrees, 360 divided by 90 is 4. So my period is 4. My period coefficient is 4 because there are 4 periods in 360. So this is the equation. I'm not sure if I occurred that here. So 360 divided by my full cycle gives me my coefficient of C, or if it's in radians, it would be 2 pi divided by the full cycle equals C. So let's try that in number 2. There's no phase shift here. So based on where this is located, I know that this is cosine. I have radians, so I know that I'm going to use X. My center line, -7 and -13, are 6 units apart, so I know that this must be at -10. Sorry, I have a Google Meets coming up, so it's reminding me. And my amplitude is 3. So y equals, I know my center line is at -10. I have an amplitude of 3. I know this is cosine based on where that peak is located. Now I'm going to go calculate my period. So for cosine, you can go from center line to center line, but I'm going to go from peak to peak, and I notice that that occurs in pi radians. So 2 pi divided by the full cycle of pi gives me 2. So I know, and I'm using X because this is in radians, and there are 1 full cycles in pi radians, so 2 pi or 360 divided by pi is 2. So that goes here. And so this is my equation. Last one. All right, so I notice now it's hard to see each box because you can't see the graph paper. Each box is 90 degrees. So there's 90, 180, 270, 360, 450, 540. It's hard to see that. Now they're saying assume sine. So if this is sine, then here is my phase shift. It's on my way up, and closest to the origin. And so in between 90 and 180, that right there is at positive 135. So that is my phase shift. My center line, 6 to negative 4, that's 10 units away. Whoops, so I'm going to divide that in half. So 5 units, that would be my amplitude. But that would also tell me 5 units, this center line would be at 1. So let's write what I have so far. I have a center line at positive 1 plus an amplitude of 5. I know this is sine. Now let's look at period. So a full cycle would be 1 peak and 1 valley. So if this is at 450, then this right here should be halfway, and so that would be 495. So this is at 495, this is at 135. So a full cycle happened in 360. 360 divided by 360 is 1. So I have a period of 1 theta, and I had a shift of positive 135 degrees. You do not need the 1 here, but that is our equation. I know that's a lot, so I'm going to write what we're skipping in homework here. So for homework, you're going to skip. So if you guys ever need help with that, I am available on Google Meets anytime. You are going to skip numbers 5, 22, 27, 28, and 30. And sorry, that completes the section.